So that's your initial momentum. Do you have a calculator with you?
No. Just use my phone.
Okay. And then it gives you a little graph, right, for your impulse. I think it's, where did it go? All right, here.
Yep.
So this is 300 newtons. And 8 milliseconds.
Yeah. How much is a millisecond then?
A millisecond is 1,000th of a second. So this would be 0.008 seconds.
And so a tenth of a second is
We don't really use it, but it'd be a decasecond.
okay.
So every now and then, like,
We would just rather say hundredths of a second rather than decasecond.
well, hundredths of a second would be centisecond. There's some, especially in engineering, there's a lot of prefixes we don't use. So if you go, I think it's in the front of the book here. See all these? So, femto, pico, nano. We use nano, micro, milli. And then there's centi. So they actually skip some of these. So you actually got, so like 10 to the second is hecto, I think. 10 to the negative second is that's centi. 10 to the first is deca. 10 to the negative first is deci. But we don't use those ones because they're not very useful. It's easier to say 0.1 or 0.02 or something like that seconds. So we don't really worry about hundredths of seconds or tenths of seconds. Instead we just say it that way. Okay? So then how are you going to find your impulse?
Equals the change in momentum.
Okay? So that'll be helpful because that'll help us know how our momentum changed. But what do we need to do to find that?
Oh, so we need to find the area of the triangle
Right.
first.
So J will be 1/2 the base times the height.
I got one. Yeah, one.
Okay, so that's the area under here. And Jy is also equal to the change in momentum. And is that going to be positive or negative?
Negative.
Well, that would mean that the floor would knock it even further down, right? What does the floor do? Which direction
Back
is?
up.
Yeah.
So this is our after.
Well, this is our change in.
Okay.
So our initial is 0.626.
Which is what we use to find our after. Our
This is negative, I
1.2.
guess. So your change in P is equal to P final minus P initial, right? So 1.2 equals P final minus negative 0.626. Okay. So we add this to the other side, which means we subtract it. So we do 1.2 minus 0.626 equals P final.
0.574.
So P final equals 0.574. That's our after right here. So in order to find how high it bounces, what do we need to know now? It's speed, right?
Yeah.
So 0.574 equals mass times the velocity after, right? So 0.574 divided by the mass of 0.1 equals your velocity after. So what's your velocity going to be?
Um, 0.0574.
It'd actually be, so when you divide by 10th, yeah, it'd be 5.74. So velocity equals 5.74 going up. And then how do you find out how high it will go? So we use this equation, right, to find out how fast it would be going when it hit the ground.
Okay.
Now we can actually use it to get rid of all this stuff. How fast will it be going when it gets to its highest point?
0.
Okay, so V final equals V initial, V final squared plus 2A change in Y. We know this, we know this, we know those, and this is what we're looking for. Right? So if the final velocity is 0, our initial is 5.74, square that, 2 times 9.8 delta Y. See where all that came from?
And we're going to solve for delta y.
Yep.
Okay.
So we'll add this to the other side, and then divide by this. So we'll have delta y equals 5.74 squared over 2 times 9.8.
I'm going to write some of this down real quick.
Yeah, go ahead. And this is all right here anyway. They go through the whole thing.
Oh, they do? Okay, yeah, I can see the stuff there.
But they just don't give every single part of it. So you have to watch out. But yeah, that's all in there. So I'm
Okay,
going to go through it. Okay. So 5.74 squared over 19.6. What's that?
It comes out to be 1.68.
Okay. So delta y equals 1.68 meters. So if you have a ball, you drop it from 2 meters, it hits the ground and it has that impulse, it'll bounce back up to 1.68 meters. Does it make sense that it would only go to 1.68 meters?
Yeah.
Yeah, because it started at 2, it probably won't bounce back quite as high, so